Hello everyone, in this video we're going to talk about how you add together binary numbers. So we're going to talk initially about the golden rules for binary addition, and then actually how to do binary addition on two binary numbers, and then overflow errors, what they are and how they're kind of relevant to everything that's happening here. My advice to you is if you haven't seen the binary numbers video on conversion, then it's probably worth watching that first, as some of the content on here relates directly to that. So before we go any further, we need to talk about the golden rules of binary addition. Now, it would be worth writing these down so you can refer to them a little later on. The first ones, you're going to feel like this is stupid, why the hell am I writing these down? But it is relevant, it is important. So firstly, 0 plus 0 is 0. I know. 1 plus 0 is 1. And yeah, 0 plus 1 is 1 as well. I know. I always say this whenever I'm teaching, just write them down. I guarantee you will make a mistake at some point regarding one of these three things and you're going to feel particularly stupid. So worth writing them down now so you don't make yourself look stupid shortly. But the ones you need to make clear attention to are what 1 plus 1 are and what happens if you get 3 ones. Now, obviously, binary doesn't go to 2. It's 0 and 1. There is no 2 at all. It's not allowed. So what we do is we say 1 plus 1 is 0, then carry the 1. Like in normal maths, if I was just to draw down here. So in normal maths, you might be like, oh, well, 9 plus 3 is 2, carry the 1, isn't it? We all know that that's 12. But in the same way, binary is 1 plus 1. Then you go, well, it's 0. And then you carry the 1 over, because there's no other space to carry that information to inside of one unit. So we put the 1 here. And that's how that works. Similarly, if we were to have 1 plus 1, and then you would have another 1 carried underneath, and which we'll show an example a little later, it'll make more sense in an example. What will happen then is you go, oh, I've got a 1 here, and then I still have to carry that 1 over, so it looks like I've got a 1 there as well. If you've got 1 plus 1 with the carried 1, you just put 1s everywhere. But the main one you need to remember is that the 1 plus 1 is 0 carry 1. Okay? If this becomes difficult to work out, remember our little binary table. Let's draw a little example of it from earlier. If I was to put 1, 0 in here, the same as I've got here, that's 2, isn't it? So 1 plus 1 is 0 carry 1, which is technically 2. But for the moment, just focus on the actual mechanics of it. 1 plus 1 is 0 carry 1. And as I say, if you haven't written down all of these binary rules just yet for your own notes, it might be worth doing that. You can pause the video, write them down, and then you've got them available when we do the example in a second. And then it'll make a bit more sense, I would argue. So adding together two binary numbers then. Now, if we remember our rules, this is very straightforward. So firstly, we'll start on the right-hand side. Always start on the right-hand side, like you would do when adding a normal number. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1, remember, normally would be 2 in normal maths. We go 0 and then carry the 1 to the next column on the left. So 1 plus 1 is 0 carry 1. Now, normally you would have 0 plus 0, which would be 0 as well, obviously. But you've got this extra 1 carried underneath. So that would mean this needs to be a 1 because it's 0 plus 0 plus your 1 underneath. So 0 plus 0 plus 1 is 1. Then you've got 1 plus 1 again, same as what we have earlier. So that would be 0 carry 1. Now here you would think, well, that's 1 plus 0. That obviously is 1 then, but it isn't. Okay, you've got the 2 1s here because you've got the 1 and the 1 that was carried. So it's actually, this is the same as this really. So that is 0 carry 1 as well. Now, 3 1s here, 2 1s at the top, 1 carried. Again, we need to refer to our rules. If you've got lots of 1s, you put lots of 1s. So 1 plus 1 with 1 carried is 1 carry 1. And same as we had a second ago over here, 0 plus 0 is 0, plus your carried 1 is 1. Now, I know that's right, but I've done this a lot. It's one of these where you just have to do it a lot to work it out. But there's a better way of actually checking it and confirming it. And to do that, we can use our binary numbers and the actual table, similar to what we did converting them last time. Now what you can do is you can actually make a little check here. You don't have to do this by any means, but it is good as a little bit of a comfort blanket to prove that you've got it right. So what we can do is we can convert this number into normal denary, this number as well into denary, and the bottom one, and therefore these two numbers should add together to make this one. Let me show you what I mean. So we've got 64 and 16 here, which is 80, plus 32, which is 112, and plus 5, so that one is 117. And then we've got 64 and 16, again 80, 4 and 2, so that one is 86. And then these two numbers are worth knowing add together. I don't know if I mentioned it in my other video. These two numbers are 192. So it's a number worth remembering because it's the biggest number to add up. And if you do remember that, 192 plus 8 is 200 plus 3. So 203. Now hopefully you can see where we're going with this. If you were to add these two numbers together, those two numbers together do indeed make 203, proving and confirming that all of this has been done correctly. So let's move on. So at this point, you probably want to pause the video, have a little go at yourself at working out the two binary additions in front of you. Okay, so first we're going to do the additions. We'll do the checks afterwards to prove what we've got is right. So I'm going to go through these quite quickly. So 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, carry 1. 2 ones here still, so 1 plus 1 is 0, carry 1. Then 0, carry 1 again. 1, 1, and 1. Let's check this one through. We've got 192 at the top, plus 7. So that is 192 plus 5. I think you can remember the other one, so that's absolutely fine. I'm going to check that for my own sake now. 192 plus 4, 196, plus 1, 197. Whew, that's a close one. Right, so then we've got 16 plus 4, which is 20, 8 plus 2, which is 10. Those two added together is obviously 30. And adding those two numbers together would be 227, but let's just double check. These three numbers added together is 224, another number worth remembering, plus 2, plus 1, that's 227, which confirms that we are right. So let's do the next binary addition. So we've got 1 plus 1, which is 0, carry 1, 0, carry 1, 1, carry 1, because we've got 3 ones, and again, 1, 1, 1, 1. Okay, so we've got 15, all these numbers added together is 15, plus 64, that is 79. We've got 160, when grouping that's just easy for those two to work that out, 160 plus 12, which is 172, plus 1, 173. And underneath, this is a little trick we can do, if you remember from our previous video, all of these numbers added together is 255, but we don't have 2 or 1. That must mean that this is 252. And doing the addition, we can see that that is all accurate as well. So we've definitely got that one right, which is excellent. However, there can be instances of something called an overflow error. Let me just complete this binary addition so we can see what I mean by that. So if we were to do this normally, we'd have 1, 0, 1, 0, 0, carry 1, 1, carry 1, 0, carry 1, 0, carry, hang on, we've got a 1 here, and we've got no space to put it. So this is an issue, obviously. Now, we know, and you should fleetingly mentioned it last time, is that we have 8 bits in a byte, and bytes what we use in the memory of computer and the storage to kind of hold data. So if in a hypothetical situation where you had a terrible computer which only had 1 byte's worth of storage, you would literally only be able to store this bit of information here. So this extra 1's been carried, and there's nowhere for it to be carried to. So you'd add up these two rather large numbers, and end up with 37, and that's not big enough. So we need to sort that out. Now, if you remember how we produced these numbers in the first place, what we did is you take the 1 on the right-hand side and you multiply by 2 each time. So you can keep going and going and going and going. Now, hopefully some of us have worked out that 128, you need to double that. You need to double that so you've got an extra column on the right-hand side, left-hand side here, so you can put 256, which is 128 doubled, on the left-hand side. What that means is you can put your extra 1 here. if this was actually inside of a computer, what we'd do is we wouldn't create just one extra column, we'd actually create 8, because a computer works in bytes of 8, so you'd actually write 8 extra here. I haven't got space on the iPad, but I would write 8 extra ones. But for the basis of just a simple binary addition like this, you're perfectly welcome to just put the one column on the left, and that'd be fine. Again, you could do the addition and confirm it, so let's do a quick check. We've got 160 again, 180 on this first one here. And then we've got 64 and 16, 80, plus 32 is 112, 113. So that should leave us with 293, which if you add these three numbers together, does actually confirm out at 293. So that does work. It still works, you just need to remember to add an extra column on the left-hand side. So again, take a few moments just to have a practice yourself at doing this with that knowledge in mind. Okay, let's have a go. So 0 and 0 is 0. 0 and 1 is 1. Let's rip through these. 1 plus 1 is 0, carry 1. 0, carry 1. 1, 1. 0, carry 1. 0, carry 1. Don't forget 2, 5, 6 in the top. Then let's get these converted. So we've got 204 at the top here. Then we've got 96 and 6. That's 102. Nice clean numbers to add together. Then we've got... these numbers add together. You can add them together this way first using these numbers and then confirm it. For this example, it's just a little easier to do that, so I'm going to go for 306 here and then confirm that is 306. Well, we've got 256 here, plus 48, plus 2. That's going to get us where we need to go because these three are added up to make 50 and 256. That's definitely right. Let's do one more quick addition. So that's a 1, that's a 0, carry 1, 0, carry 1, 0, carry 1, 0, carry 1, 1, carry 1, 1, carry 1, 0, carry 1. Remembering we put that on the far left-hand side. Again, converting these three numbers is 224 plus 2, 226. And then, if you remember another trick we can do, I'm not even going to mention it. Check the other video. It's important to check it out. 127. We can work that out instantly, which is very nice to do. It's one less than 128. So that works out nicely. Okay, we can add these together. We've got these two, which group together, as do all the other groups if you pair them like this. These two group together to make 320. 320 plus 32 is 352, plus 1, which is 353, which is perfect, proving us that we've done it exactly right. I hope this was useful. Again, if you're not sure, please leave a comment down below. This is as complex as binary addition gets with regards to the GCSE, so if you do need to do anything GCSE related, as long as you know that an overflow error, we add an extra byte if the number goes over 255. And you can see that because this number here is 256. So if it goes over 255, it's going to need that extra column on the left. And that's all you need to know regarding overflow errors. Everything else is as complicated as we've just done here, so completely manageable. Right, thank you for watching.